Superclusters are conglomerates of tens of thousands of galaxies, held together by gravity in groups or clusters. Cosmological theory says that the universe began to expand about 15 to 20 billion years ago, starting with a tremendous explosion. This event on day 1 of the cosmic calendar is called the Big Bang.
The solar system consists of the Sun and all the celestial objects orbiting it. The system includes the 9 large planets and their 61 known satellites, the planetoids and periodical comets. All planets revolve around the Sun in the same direction in individual orbits.
The Milky Way is a spiral galaxy with a diameter of approximately 100,000 light-years. Our planetary system is located on one of its spiral arms, called the Orion Arm. The Sun, the central star of our planetary system, is approximately 32,000 light-years from the center of the galaxy. Our Sun will undergo major changes over the next 5 billion years. Its energy reserves will at some stage be exhausted. The cooling of the outer layers will turn the Sun into a red giant, swallowing the inner planets of the solar system. The Earth will reach a temperature of several thousand degrees Celsius, and its surface will dissipate. It is estimated that it will take another 200 million years until the Sun will start to shrink to a white dwarf. The Sun consists of an inner core, a radiation zone, and a convection zone, and also has an inner and outer atmosphere, referred to as the chromosphere and the photosphere. The latter two are the layers where visible solar activity takes place. The energy of our Sun, which is a main sequence star, derives from nuclear fusion reactions taking place at its center. The nuclei of hydrogen atoms, also called protons, interact with each other, resulting in a chain reaction. The energy is ultimately transformed into high-energy gamma rays, which eventually reach the surface of the Sun. The energy of the Sun comes to the Earth in the form of sunlight.
Gas eruptions on the surface of the Sun can reach a height of several 100,000 kilometers. These phenomena are called protuberances and often result in solar material being hurled far out into space. The Sun rises each morning in the east. The light is dispersed by various layers of the Earth's atmosphere, and darkness recedes. During its course through the day, the Sun rises gradually to a high angle above the horizon, resulting in a different refraction of the light. The sky appears clear and bright. In the afternoon, the Sun stands at a lesser angle, and in the evening, after a period of twilight, it finally disappears behind the horizon to the west.
Mercury orbits the Sun at a distance of approximately 58 million kilometers. Due to its proximity to the Sun, Mercury orbits faster than any other planet and revolves about the Sun in an 88-day cycle. Mercury is the planet nearest to the Sun. It consists of an iron core, a mantle of silicate, and a thin rocky crust. Its surface is shaped by numerous craters.
Mercury is visible from the Earth only for a short period, just before sunrise or after sunset. In the evening, Mercury is visible if it's located to the left, that is, east of the Sun. Here, the largest possible angular distance to the Sun is called the maximum eastern elongation to the Sun. Accordingly, Mercury is visible to the right, that is, west of the Sun at sunrise. At this point, the largest possible angular distance is called the maximum western elongation. Mercury is visible for a maximum of 2 hours. Venus is the second planet from the Sun. It rotates about its own axis within 243 days, which is the longest rotation period in the solar system.
Venus consists of a liquid core of nickel and iron, covered by a mantle of mineral material. The surface of the planet consists of a silicate crust, displaying the characteristics of a hot desert with highlands and lowlands. Like Mercury, Venus revolves around the Sun inside the circle described by the Earth's orbit. The planet appears to us in different phases, similar to those of the Moon. An upper conjunction occurs when Venus is located behind the Sun, and the Sun is thus positioned between the planet and the Earth. A lower conjunction describes the situation where Venus is located between the Sun and the Earth.
Mars is the outermost of the Earth-like planets. Its cycle of rotation on its own axis is 24 hours and 37 minutes. A Mars day is therefore only slightly longer than a day on Earth. Mars has 2 small satellites of only a few kilometers in diameter, called Deimos and Phobos. They revolve around the planet in separate orbits. Mars consists of a small compact mineral core and a silicate mantle. Its solid crust is covered by a thin atmospheric layer of mainly carbon dioxide. The rust-colored surface of Mars features mountains and deep gorges, as well as numerous craters and impact basins. Jupiter is the largest planet of the solar system, with a rotation period about its own axis of 9 hours and 55 minutes. The 16 moons of Jupiter orbit the planet in 3 groups. The 4 moons farthest away revolve in the opposite direction to the other satellites, and are more than 20 million kilometers from the center of Jupiter. Jupiter has a small rocky core surrounded by an inner mantle of ionized hydrogen and an outer mantle of liquid hydrogen and helium. Its thin atmosphere also consists mainly of hydrogen and helium. The surface of Jupiter is shielded from view by bands of coloured cloud.
Io is one of the most active moons in the solar system. It features many large active volcanoes. Attracted by the gravitational force of Jupiter, plumes of sulfur are propelled into the atmosphere of the satellite. Saturn is characterized by its fast rotation about its own axis and its ring system. It has 18 confirmed moons. These satellites orbit the planet in small groups, sharing similar orbits. Phoebe, the farthest of the Saturn moons, revolves in the opposite direction around the planet. Saturn consists mainly of hydrogen and a small percentage of helium. Around its core of ice and rock, there is an inner mantle of ionized hydrogen and an outer mantle of liquid hydrogen. Its atmosphere also consists of hydrogen and helium. The surface of Saturn is covered in clouds, while its rings of water-ice particles appear bright and luminous. Uranus rotates on an axis, which is considerably tilted towards its orbit. The planet features 11 rings made up of rocks and has several dust belts between these rings. There are 15 confirmed moons revolving around the planet in synchronous rotation.
Uranus has a solid core and a mantle consisting of water, ammonia and methane. Its atmosphere is mainly composed of gaseous hydrogen, helium and methane. The rings of Uranus consist of rocks with interlaying dust belts and are relatively narrow.
Neptune features an inclination of its axis to its orbit that is very similar to that of the Earth. The planet has a ring system and 8 satellites in individual orbits. Nereid is 5.5 million kilometers distant from Neptune and is thus the farthest satellite of the planet. It orbits in the opposite direction to the other moons. Neptune has a small solid core made of rock. Its mantle consists mainly of water ice, methane, and ammonia, and its atmosphere contains mainly hydrogen and a small percentage of helium and methane. Neptune is covered in a layer of clouds and features a system of rings. Pluto has a large core consisting of rocky material, surrounded by a mantle of water ice. Its surface also consists of water ice and frozen methane. When Pluto is closest to the Sun, a thin atmosphere of methane, possibly mixed with nitrogen, is built up.
Pluto is the most distant planet of the solar system and revolves around the Sun in a cycle of 248 years in an extremely elliptic orbit. Charon is the only satellite of Pluto and similar in size to the planet itself. The two objects are therefore often referred to as a double planet system. Our Earth is made up of a solid inner core and a liquid outer core. Its mantle and crust consist mainly of solid rocky material. The atmosphere of the Earth is made up of 77% nitrogen and 21% oxygen.
The Earth is the third planet from the Sun. It revolves around the Sun once every 365.25 days, with a rotation cycle about its own axis of 23 hours and 56 minutes. The Moon is its only satellite and has a rotation cycle on its axis of 27.3 days. This is actually roughly the same period of time that it takes for the Moon to complete one revolution around the Earth.
The magnetic field of the Earth extends far out into space. Its magnetic flux lines originate at the north and south poles. The geomagnetic field arises from the convection flows in the Earth's interior. Comets consist of dust particles and frozen gases. When a comet approaches the Sun, the heat causes the comet's surface to evaporate. A massive glowing ball around the core of the comet appears, and the comet develops a straight tail caused by the solar wind. This great tail is directed away from the Sun, while there's often also a smaller curved tail made up of dust particles. The orbits of comets are extremely eccentric compared to the orbits of planets. As it is the solar wind that creates the comet tail, this tail is always directed away from the Sun. The farther away the comet from the Sun, the smaller its tail.
Meteors are illuminations in the sky caused by meteorites entering the Earth's atmosphere. The common name for this phenomenon is a shooting star. Meteors are bodies of rock or iron that whirl around in the Earth's atmosphere. Most meteors dissipate there, and on clear nights we can admire the resulting shooting stars. A meteor that penetrates the atmosphere and reaches the surface of the Earth is called a meteorite. Meteorite impacts create craters of various sizes, though most meteorites fall somewhere into the oceans unobserved.
During clear nights, the zodiacal light is sometimes visible as a faint glow near the horizon. This phenomenon is caused by the dispersion of sunlight by small interplanetary dust particles, especially by the particles located between the Sun and the orbit of the Earth. The result is a faint band of glowing light, which is distinct from the normal twilight. The corona light of the Sun results from the dispersion of sunlight by interplanetary dust and free electrons.
The radiation pressure blows charged particles away from the Sun. This phenomenon is called solar wind. The solar wind also influences the magnetic field of the Earth by giving it a pear-shaped appearance. If particles of the solar wind are trapped near the geographic poles of the Earth, they manifest themselves as the aurora light, also called the polar light. In addition to the 9 large planets, there are numerous planetoids orbiting the Sun. Their diameter is rarely greater than a few kilometers. Most planetoids in the solar system are found between the orbits of Mars and Jupiter, revolving in individual orbits around the Sun. In addition to the
Star systems, such as our Milky Way, are called galaxies. Scientists distinguish between various types of galaxies, such as spiral galaxies, barred spiral galaxies, elliptical and irregular galaxies.
The Milky Way is a spiral galaxy consisting of several hundreds of billions of stars and interstellar matter. Our planetary system is part of the Milky Way. The astronomer Hubble developed a classification system for galaxies. On the handle of his tuning fork diagram, there are elliptical galaxies. On the 2 arms of the tuning fork, we have the normal spiral galaxies at the top and barred spiral galaxies near the handle. Galaxies are further classified within these groups according to their shape.
Elliptical galaxies are so called as they were first observed as hazy spots in an elliptical shape. We know today that they can also be of globular shape. Such galaxies consist of between a few million and several thousands of billions of stars, and thus vary greatly in size. In the center of a spiral galaxy, we find a globular conglomerate of old stars. The spiral arms contain mainly young stars and nebulae. Barred spiral galaxies consist of a straight bar in the center which fades out at both ends. At the ends of the bar and at a right angle to it, there are spiral arms. The size of the nuclei of these spirals varies, as does the shape of the spiral arms.
Irregular galaxies have no discernible structure. They are normally only a third of the size of elliptical or spiral galaxies. Their irregularity is most probably due to gravitational interference by the large galaxies. One of the best-known galactic clusters is the so-called local group. It consists of approximately 30 different galaxies, including our Milky Way and the Andromeda Galaxy.
Quasars are star-like objects and are extremely distant from the Earth. They are probably galaxies at an early stage of development, emitting intense radiation from a nucleus. Scientists contend that the energy for this radiation derives from a black hole.
Stars move with relatively high velocity through space. From the Earth, this motion is only observable over periods of 50,000 to 100,000 years, as the stars are very distant from us. The Hertzsprung-Russell diagram illustrates the relationship between the surface temperature of a star and its luminosity, or radiation of energy. The main sequence, which is a diagonal line in the diagram, indicates the stable phase of a star. Most stars are located along this line. In the upper part of the diagram, we find the giants, while white dwarfs that have exhausted their energy are located in the lower part of the diagram.
The outer layer of a red giant consists mainly of hydrogen. In the inner layer, fusion reactions of hydrogen nuclei producing helium take place. Near the very core of the red giant, helium fuses to carbon, resulting in temperatures of up to 100 million degrees Celsius. A star begins its life as a gaseous nebula. In the case of a star similar to our Sun, this cloud starts to contract and shrink with a subsequent rise of temperature until it finally starts to shine like an actual star. This state is then maintained for the next approximately 10 billion years. Subsequently, the star gradually swells and becomes a red giant. At a later stage, the star sheds its outer layer, which forms a planetary nebula and exposes its core. Such an object of high density is called a white dwarf. White dwarfs are about the size of planets. As they have exhausted their energy, they gradually cool down until they finally become black dwarfs. Pulsars are rotating neutron stars emitting pulsing radio waves into space. Pulsars have a diameter of approximately 10 kilometers and consist mainly of neutrons. They spin rapidly while emitting two intense beams of radio waves in a regular sequence. These emissions are observed as short-pulsed radio signals. The phenomenon is most likely related to extremely strong magnetic fields. A short beam of radio waves is observed at each rotation of the pulsar, very similar to light beams from a lighthouse. Double stars are two stars that appear close to each other in the sky. They may be two stars positioned in the same direction from the Earth, but at different distances to it. In such a case, the double star is simply a visual phenomenon. There are, though, actual two-star systems consisting of stars that are physically close to each other and that revolve in orbits about their common center of mass. Such double stars are called binary stars.
Star clusters are dense groups of stars. They are classified according to their density. Barnard 86 is an example of an open cluster. There are further globular clusters where the stars at the center are densely packed to the extent that they cannot be clearly distinguished. Open star clusters are mainly found on the spiral arms of our Milky Way. They consist of up to several hundred stars and loose conglomerates. A well-known open cluster is the Pleiades.
Globular clusters consist of several millions of stars, which are very densely packed near its center. They often contain very old stars. Some of them are probably as old as the galaxy to which they belong. A nova is a variable star. Prior to its explosion, it's probably the white dwarf of a binary star system. Matter escaping from the larger partner to the white dwarf forms a hot halo around the white dwarf. The resulting nuclear reactions lead to a thermonuclear explosion, and the white dwarf sheds its gaseous layer into space.
The term supernova describes a sudden intense increase of brightness of a star. This indicates the final stage of evolution of a massive star. The outer layers of the star are ejected into space, and the resulting massive explosion is called a supernova. Black holes have an enormous gravitational pull. All their matter is densely packed, and not even light escapes their gravitational field. If elementary particles such as electrons and their antiparticles are pulled toward a black hole, one particle may fall into the hole while the other escapes and forms a radiating ring around the black hole. A black hole may start to shrink if particles escape its gravitational field without losing their energy. Subsequently, the black hole may finally dissipate and disintegrate in an enormous explosion.
A planetary nebula is a gas cloud surrounding an aging star that has shed its outer layer. This star has often lost its luminosity and is barely visible. Induced by the remaining energy from the star at its center, the gas cloud radiates and is visible for tens of thousands of years.
Along the orbit of the Earth around the Sun, the angle at which the sunlight reaches the Earth varies. In summer, the sunbeams reach the surface at a more pronounced angle than in winter, resulting in higher temperatures. In winter, the solar energy is more widely dispersed, as the rays reach the surface of the Earth at a lesser angle, resulting in lower temperatures.
The cycle of day and night is the result of the rotation of the Earth on its own axis. The period of daylight, that is, the period between sunrise and sunset, varies during the course of the year. Depending on the ecliptic angle of the sun, nighttime and daytime periods vary. In the course of a year, the sun appears to complete a path in the celestial sphere through the signs of the zodiac. These signs are commonly grouped by season. The moon reflects the sunlight and appears to the observer on the Earth in different phases, from a thin crescent-shaped semicircle to a full moon.
A solar eclipse occurs when the moon is between the sun and the Earth. Its shadow covers parts of the surface of the Earth, and for the observer, the sun appears covered by the moon. Eclipses occur as total, partial, or annular eclipses, depending firstly on the location of the observer, and secondly on the relative positions of the sun, moon, and Earth. A lunar eclipse only occurs when the full moon crosses the orbit of the Earth and enters the shadow of the Earth. During a lunar eclipse, the moon does not disappear from sight fully, but appears in a rusty light. This effect is the result of a partial reflection of sunlight into the shadow of the Earth by the Earth's atmosphere.